A while ago I made a video about these microphone sensor modules that's been very popular, and in that video I focused on the digital output and how to set it up. But today I want to look at the analog output that I didn't discuss last time, and I get quite a lot of inquiries about that. And basically that just enables you to take the signal from the microphone and use it as you would with any other microphone. And the benefit of being on the little board, the module, is that it's given the correct power, VCC, and is all set up and ready just to go from one pin and a ground. So if you look at the schematic, there's the variable potentiometer that's actually for triggering the digital side, and another resistor as well, but it's a very simple circuit, and it just feeds the output of the microphone to the pin marked A out. So anyway, now let's have a look and see how it works. And before that, I might just mention that you can use these microphones on their own. They don't have to be on a board, in which case you just add a resistor to give it some voltage. It needs 5 volts and a ground because it's a condenser microphone, so it needs some power. And I'll show you later how I used that in one of my projects. So now let's take a look at this on the breadboard and give it a test and see how well it works. Here's the microphone sensor module plugged into a breadboard, and you can probably see, I hope you can see, that the top connection here is where I'm pointing is the analog output, and the next one down is the ground connection, the next one down is the VCC, which is 5 volts, and the last one here is the digital output, which is not connected to anything. But as you can probably see, this LED is flashing because I've adjusted this potentiometer already, and the digital aspect of this module is picking up my voice as it triggers it. So it's set just on the point where it lights up if it hears a sound. And if that was connected to an Arduino, a Raspberry Pi or any other processor, that could trigger an action to happen. But today I'm interested in the audio output. Does it feed through a good signal from the microphone? Can we see it on the oscilloscope? So let's try it. I'll just focus into the oscilloscope, and I'm going to use an app on my phone that generates a tone and turn it on, and hopefully we'll see something on the screen. There we go, I can see it happening. As I get closer to the mic, we can see something a bit like a sine wave. And yes, that microphone's picking that up fine. It's just coming straight out and straight into the oscilloscope, and we can see it's working properly as a microphone. So the next step would be to see what practical uses we can put that to, and if there's a signal that you could perhaps speak into and be of reasonable quality to use. So I'll set some more things up and we'll give that a try. Here's a practical use for this microphone sensor module. I just want to test if I can use a microphone with this circuit here. Now this is a chip that detects a particular frequency. So if the frequency is around 600 Hertz, this green light will come on, and you can see it's flashing occasionally with overtones from my voice. So I've connected the output, the analog output, to the input of my circuit. And I'm now going to play a tone. So here we go, here's a tone. And as I reduce that in frequency, hopefully the microphone will feed it in and we'll see it light up. So here we go. It's beginning to light up, yep. It's working well, and the tone detector has locked onto it. And as I change frequency, you see it stops. So it's obviously working. So now let's try another demonstration. Now it's time to test the microphone module and see if the tiny little microphone will pick up my voice and actually record something. So I've taken the analog output and connected it to this 3.5mm jack, mini jack, and that's going into this handheld recorder. And if I turn that on, we should see my voice is making the, let's just focus that on there properly. It's making the level jump a little bit, so I think it's picking me up. When it's plugged into the line input, it switches off these microphones up here. So this should be quite straightforward. It's a very crude circuit. I've just joined it straight to the recorder. There's no capacitor or anything in between, so let's hope it's all right. So now it's time for me to record something. I'm just going to press record and just sit here about 40 centimeters away from the microphone, maybe 50, and just speak in a normal voice and see how it sounds. The owl and the pussycat went to sea in a beautiful pea-green boat. They took some honey and plenty of money wrapped up in a £5 note. Okay, stop recording. And I'll just play that back and see if it makes any sense. The owl and the pussycat went to sea in a beautiful pea-green boat. They took some honey and plenty of money wrapped up in a £5 note. Now that's actually pretty good. I'm quite away from the microphone. I was speaking quite gently, and I think that's the secret of this at the moment. Obviously, if you used it for real in a radio or something like that, you'd need some other circuitry, some capacitors, maybe a buffer amplifier or something, but it shows that these microphones work. And in a moment I'll show one more use I've put it to, following up on the earlier experiment. So here I have a little product I made using the circuit on the breadboard and removing the microphone from one of these modules. So I had to wire that up myself and just put some bias onto it from the VCC. I'll show a schematic in a moment. And I made this so I can home in and tune into radio signals. So if I push the button and we hear the right frequency, it will light up. Now if I put a tone on my phone and I gradually increase the frequency, there we are, it's lighting up. Now it's solid. So that should be around 600 Hertz. So what I was able to do though, first of all, was test it with one of these and then decide for real I wanted to use one of these little microphones. So it's been a very useful module, and we can see that it works. And there's a station. Let's just tune into it. There he is. So I hope you found that interesting, and I hope you found that helpful, which is after all the point of making these videos. I found these little modules very useful. Maybe you will too. They're fun to use in projects, and of course you can take them to bits and use the individual parts as I've done with just the microphone. So that was fun, and I'll be making more videos soon about amateur radio, electronics and other aspects of technology, I hope. And so thanks for watching.